Hello friends, today I have given you one of the question bank where few examples are there. Now those examples you may not find in the books which will be available with you, and those questions are among four questions. There are two questions which was previously asked in the GTO examinations. Now you might be wondering, what will be the its correct answer, and sometimes what happen is we follow the right procedure, but still we might have kind of dilemma that whether we had you know followed the correct process or not. So how exactly we can cross verify? Is there any simulation tools? So the answer is yes, there is one very easy simulation tools that you can use just to cross verify your answer after solving. Say for example, in the question number 6, it is asked to find the current which is flowing through this 2 ohm resistance through this Thevenin's theorem. Now this was the previously asked GTO examination question, and now we have to follow certain steps using Thevenin's theorem, and we have to find the answer. But I will show you that which is the software which you can use, that what are the steps you require to follow, and how it will be useful to deal with such kind of circuits. Alright, let us begin that. So there is one simulation tool called LTSPICE. This LTSPICE is very much popular software, and it is also used in industry, and it is open source. So firstly, you require to make a new schematic. So we have right now with us one schematic, blank schematic. Now you need to add some voltage source and some resistance. So here already a resistance, capacitor, inductor are given. Some diode is there, ground reference is there. This is the wiring tool where we require to connect two components. You can use that. Here run button is there. Before running you can also build circuit, but anyway, mostly if we press on it, the simulation will be run. So let us start the simulation with very basic circuit like of Ohm's law. So in order to add components, I will click on the components. Now will I take this on the right side. So there is a voltage given, so I will click on that voltage. Okay, now this is added. Now other thing which will be required is the resistance, and then I need to connect it. So I will use this wire and will connect resistance and voltage source. Okay, now always in a simulation you have to some reference point. So I have assigned reference point here. Now I'll choose a voltage and resistance value. Say for example, if my voltage is 12 volt and resistance is 24 ohm, so we know that as per Ohm's law, current flowing through this resistance is a ratio of source voltage, means V 12 volt, divided by resistance, means 24 volt, 24 ohm. So 12 volt divided by 24 ohm will result into 0.5 ampere, right? Now we can verify that. In the final step, once you build the whole circuit, you need to run on it. You have to press run button, and while you press a run button, at that time it will ask you to choose to enter the stop time. So I would like to run the simulations for 0.1 second. Yeah, so once you press OK, this entire simulations will be finished, and you will get the result. Now there are two important things we have to figure it out while solving the example. One is a voltage available at a node, and other is the current which is flowing through the passive element. So say for example, if I want to measure voltage at this particular node, So once I take my cursor on this wire, so this will be converted into probe. Say for example, if I take over here, so this is probe. Now if I click on it, so this voltage will appear over here. So this voltage is I have entered 12 volt, so 12 volt is appeared here. Now other important electrical quantity to measure is the current. So in order to measure a current, I will take my cursor on a resistance. So once I click on it, showing me a current. Okay, you can merge multiple graphs also. Say for example, firstly if I want to have a voltage on this side and current on the other side, so you can see like on the x-axis we are having the simulation time, which is 0.1 second, 100 millisecond. On the left side there is a voltage and on the right side there is a current. So this color is showing a voltage and other color is showing a current. So current is reaching to 500, which is constant. 500 milliampere means 0.5, and voltage is 12 volt. Now similarly we can build a circuit, we can construct a circuit. Say for example, if we want to figure out what will be the current through this 2 ohm resistance, so we can add the 3 voltage sources, 3 resistance, and we can wire them like this, and to enter those values in the LTSPICE, and then we have to run it, and once you take cursor in the simulation on 2 ohm resistance, it will gives you a current. So let us do that also. So let me open that. Yeah, so this I have already built this whole circuit in LTSPICE. Now only thing which is left is to enter the values. So let us do that very quickly. This is 40 volt 5 ohm. So once I right click on it, 40 volt 5 ohm, 20 volt 10 ohm, 20 volt 10 ohm, 2 ohm and 10 volt. So 2 ohm and 10 volt. Alright, now if I run it again, so it is asking me to enter simulation stop time. So I have entered it to 0.1 second. Once I click on OK. Alright, so this was previously constructed circuit and this is the current one. Now I'm interested in this current, right? I can also check the voltages at each node, okay, but right now I'm interested in this current, which will be the final answer, right? So once I double click on it, this is giving me 4.3749. so while you go through all the steps of Thevenin's theorem, and if your final answer is 4.3749 ampere, means it is correct. So in that way you can construct your circuit